All right. Hello, everyone, and welcome to the Savision webinar. This is the second one in a series that we're doing with Paul Schnackenburg from Australia, and we're very glad to host and have his time and experience and expertise on HyperV and the deep dive that he will be performing today. For those of you who are new to WebEx, there is an ability to place your questions and answers in either the chat window or in the Q&A section. We would appreciate the Q&A because then we can get them to Paul and to myself as soon as possible. Again, thank you for joining us. I just wanted to do a small introduction of who Paul is, and then what we'll do is let Paul loose on you with a very good in-depth webinar that he's been running and a good look at HyperV. And after that, we'd like to come back and handle the questions that you have. So we won't be doing the questions real time. We'll be taking pauses in between the presentations, and then at the end we'd like to obviously talk a little bit about a Savision solution that tags nicely on with some HyperV monitoring that you may be doing already, called Cloud Reporter. A little bit about Paul. Paul Schnackenburg has been in IT since the days of 286 computers, so he's been around with us for a long time. He works part-time as an IT teacher and runs his own business, Expert IT Solutions, on the Sunshine Coast of Australia. So those of you planning a vacation, I'd highly recommend getting in contact with him and getting the local know-how. He has a lot of certifications from Microsoft with a lot of letters. Feel free to connect with his blog to find out exactly which ones, as I'm not going to repeat them all here because I tend to get them in the wrong order. He does specialize in Windows Server, Hyper-V, and System Center, as well as hybrid and public Azure cloud solutions for businesses. At the end of this presentation, we will show you how to get in contact with him, obviously through his email address or through his blog, tellitisasit.com.au. Yes, I've been practicing, Paul. But don't worry, we will have a slide on that one. So again, thank you very much. And Paul, take it away.
All right. Welcome, everybody, to Microsoft Hyper-V performance considerations. So Justin has given me a good introduction, and so what we're going to cover here is related to a white paper. So the white paper is available on Savision's website to download for free, and it's got an in-depth coverage of Hyper-V from a performance point of view. So lots of businesses are now looking at moving to Hyper-V from VMware, and there's a couple of reasons for that. I'll go to the next slide here, if it's going to let me. There you go. And so more and more businesses are looking at Hyper-V, and of course in that context they need to look at how they're going to manage performance. So there's two parts to that. The first one is planning. So you want to plan, and before you go out and just buy a few servers and hope that it's going to work all right, you want to do some planning, and that's what we're going to cover in the first half here. And then if you do have performance issues down the track, we're going to look at how to find those issues and track down which component is the issue, and see what we can do about fixing that. So, Hyper-V for private cloud. So Hyper-V has been around for a few versions now. The first couple of versions back in the 2008 time frame were a bit laughed at by the IT industry in general. VMware's solutions were certainly much better back then. But over the last couple of versions, especially since 2012 and further improved in 2012 R2, we are now looking at a very good hypervisor, which is built into Windows Server. So it is cost effective, especially compared to VMware, which really have to charge for the hypervisor, and although they do have a free one now, but they have to charge for the management tools, etc., because that's how they make their money. So there is a free Hyper-V server that you can download. It doesn't come with a GUI and it can't do anything else, but it is a full-fledged hypervisor with no limitations. It can do clustering and everything else. If you go with a data center version of Windows Server, then you get unlimited amount of VMs, Windows VM servers running on top of that hypervisor. The other big reason I think that I'm seeing more and more and hearing more and more when I'm looking at reports that Hyper-V is becoming more and more popular is because of the hybrid cloud. So Microsoft Azure runs on Hyper-V, the 2012 version, and that makes it much easier to move workloads to and from Azure, and thus build hybrid cloud solutions. And VMware does not really have that solution today. They do have a couple of data centers, but they do not have the scale that Microsoft Azure has today, with 19 regions around the world and more coming online all the time. So when we look at building a hypervisor platform for your private cloud, you're going to have a bunch of VMs running on there, both Windows and Linux. You want to do some planning. You want to think it through before you go ahead and just write your check to get the hardware ordered. And there's lots of options in there, and you need to sort of pick the technology. So you need to know which technology match up with the needs that I have. And if you can't, if you don't know the technologies and if you don't plan for that ahead, you might paint yourself into a corner. And if you do get a well-planned environment, it's much easier to then find where the performance issue is. Now, obviously, I'm talking about a nice greenfield solution here, where, that's all unicorns and rainbows, and we are planning from day one, and we got enough budget to buy exactly what we need. And I'm totally aware of, in the real world, there are budget constraints, there are time constraints. Sometimes you're not building a new Hyper-V cluster, you're setting up some sort of addition to an existing cluster, and the boss tells you have to keep this running for another 3 years, and that's just how it is. We don't have any money. So I understand, but still, understanding the technologies and planning up front, even if it's only a couple of new servers added to an existing cluster, can make a big difference. So we look at the hosts first. These are the physical boxes that run the hypervisor. Obviously, you can have a single host, maybe in a small branch office or something like that, but in your data center, you're very likely to want to have clustering. You can build up to clusters with up to 64 hosts, and any kind of clustering requires shared storage. So if you have a SAN today, a storage area network, it can be either iSCSI or fiber channel. Hyper-V plays really nicely with both of those technologies, no problems at all. If you have a smaller setup, so 2 or 4 servers, there are cluster-in-a-box solutions that you can buy from manufacturers, and they have shared storage built in, directly connected between those 2 or 3 or 4 hosts. In anything larger, you may want to look at the scale-out file server, or SOFS, from Microsoft, which also came in the 2012 Windows Server version, together with the SMB 3.0 protocol, and that makes it possible to store both Hyper-V virtual hard disks for running virtual machines and SQL Server databases on a file server. So that's the power of having the scale-out file server as your storage. So the next planning phase is looking at how many cluster nodes you need. How many can you afford to have down? So the reason I've got the overhead there is that it's better to have smaller hosts and buy more of them than having fewer hosts that are really powerful, because of the overhead. If you only have 2 hosts in your cluster, and one of those hosts is down because you need to do maintenance or patching or whatever, then the other node has to be able to run all the virtual machines, which means that you can really only use half of your cluster capacity. However, if you have 4 hosts and you plan for having 1 down, well, then the remaining 3 nodes just take a third of the load each, so you only lose 25% of the cluster. And as you can see, if you go up to 8 hosts, the overhead of having clustering becomes less and less. Now, obviously, this depends. If I have a 16-node cluster, maybe my boss tells me I have to survive 2 hosts down, but still, you get the idea. More hosts is better than fewer hosts. Obviously, you need to, if you're going to have a SQL server that's going to require, 80 gigs of memory, then you need to make sure that you have nodes that are big enough to accommodate those sorts of workloads. And you should certainly, on any kind of new installation, you should use the latest version of Hyper-V, which is Windows Server 2012 R2. And if you're going to run Windows Server virtual machines, use the data center version because, as I said before, you get the unlimited licensing. In the white paper, I did not mention the NUMA nodes. So NUMA stands for non-uniform memory access. You need to be aware that any server you buy today, if it's got more than 64 gigabytes of memory, and you should buy a server with more than 64 gigabytes of memory today, not all the processors can access all the memory equally fast. So that's what we call a NUMA node. It's a number of CPU cores together with a section of the memory. The one thing you need to be aware of there is if you buy hosts at different times, so that not all the hosts in your cluster are identical, and you have a virtual machine that fits into the NUMA node size on one of your hosts, and you then move it to another host, which might be an older one, where the NUMA node size might be smaller, you could get odd performance results. You could get a much slower virtual machine. So you need to read up about NUMA if you don't know what your NUMA size is. You can choose when you install Windows Server to use Server Core. That gives you less overhead and less of a attack surface from a security point of view, but you do need to know that it's a command line only with Server Core. So can your team handle that? Do they know PowerShell, etc.? If you're going to run VDI, so Windows Client Operating Systems, or you're going to run Linux on your HyperV servers, you can go with a free HyperV server because, of course, you don't need the free virtual licenses that you get with the Windows Server version. You want to choose all AMD or all Intel so that you can live migrate virtual machines between them. It does not have to be the same model across the cluster. You want to have CPUs that support second-level address translation. You can see what Intel and AMD calls it there. And you also need to support hardware-assisted virtualization and data execution prevention. Now, any CPU you have bought in the last server CPU in the last 3 or 4 years, 5 years, will support all those technologies. You want to leave your page file as system managed. HyperV does not use paging for virtual machine memory, except in one very specific situation. So just leave that to Windows to run. Now, when you install HyperV as a role in a Windows server, that installed operating system gets a hypervisor slipped in under it, and it becomes the first virtual machine. We also call that the parent partition. Now, in the host itself, you should only run management and backup agents. Do not run any other kind of workloads in there because it is not supported. So your HyperV host should not be a domain controller as well. Choose servers from Windows Server Catalog, and the stars here refers to links that are in the white paper so that you can look up more information about that if you download the white paper. When you get your brand new servers, the first thing you should do is update all the firmware, drivers, BIOS, etc. because they often ship with out-of-date software. Then when you install Windows Server, the first thing you should do is update the host with patches, and for both Windows 2012 and 2012 R2 there is a link to the recommended updates that are available for those versions. Whether you should use CPU sleep states is a question. So the fact that your CPU cores can go to sleep when they're not in use can sometimes interfere with any hypervisor. Do your own testing, and if you're not happy with the result, you can turn off sleep states. If you're using System Center Virtual Machine Manager, it actually comes with the ability to turn your hosts off altogether during nighttime or other off-peak times, and then wake them up automatically in the morning when they need it again, so that might be a better solution. And if you've got HyperV Manager running on a host, it uses up some resources, so from a performance point of view, close it down. So now, virtual machines. So the very first step that you need to do from a performance point of view, you got your virtual machines up and running, is make sure that your integration components are up to date. This used to be something we installed from the host. Now it's done through Windows Update. And I won't go into the details here. There is logical processors, which is your CPU core, unless you've got a hyperthreading on when you get 2 logical processors. The virtual processors is what you assign to your virtual machines. There is no limitations on ratios. In earlier versions of HyperV there was that, but it's not since 2012. Of course, you've got to be realistic. If you've got a quad-core CPU in your host and you have 40 virtual machines and you assign lots of CPU resources to them, well, there's no magic here. You're still going to be limited by that one quad-core CPU in your host. You should assign virtual processors based on the workload inside of the virtual machine. Not all the workloads can take advantage of multiple processors, but there is no there's no penalty for assigning more CPUs than a virtual machine might use. There is no gang scheduling overhead. You can look that up. There's a good blog post on that out on the net. In VMware 5.5 they had that issue, and earlier I don't know whether they fixed it in 6. If your virtual machine is going to be a domain controller, turn off time synchronization with the host, and maybe for other servers as well, and run a time server inside of that domain controller, or make it talk to a time server on the net somewhere. You want to run the latest operating system. Both in the Linux and Windows world, the later operating systems are better at being virtualized. From Server 2012 onwards, you can create Generation 2 virtual machines. That is appropriate if you're going to run Windows Server 2012, Windows 8, or a recent Linux as the virtual guest operating system. It doesn't have any emulated hardware. It installs the operating system faster and boots faster, but it does not run faster. And if you are using Virtual Machine Manager 2012 R2 services, they don't support Generation 2 VMs. If you're not going to use the optical drive inside of the virtual machine, remove it, because there is a scheduled task that runs every second to check whether the optical drive is there and whether it's got something in it. So that's going to cause performance issues unless you actually remove it. Not just setting to no media, but actually removing it out of the configuration. From 2012 R2 we have enhanced session mode, which gives you better copy and paste. You can access the machine even if it doesn't have an operating system on it, using a remote desktop protocol, etc. And even gives you USB redirection. Obviously if you're a hoster, that's probably not a good idea to turn that on, but if it's in your own private data center, definitely consider turning that on. You have to turn it on the host side and as well on each virtual machine where you want to use it. So networking is always interesting. Back in the day we used to have hosts with lots of 1 gigabit Ethernet connections. There was an attendee at last week when we delivered this webinar who had hosts with 12 network cards in them. Today if you buy a host, it's very likely to come with a couple of 10 gigabit Ethernet connections. And you use software quality of service to carve up that network bandwidth for the different types of traffic, backup, production network, live migration, heartbeat, maybe storage traffic, etc. From Windows Server 2012 onwards, we have options for live migration. The default is compression, so HyperV will monitor the host on each side and see if there's any free CPU resources. If there are, it will use that to compress the data stream going from one host to another, and it gives you about a 2x improvement. The old TCP/IP is still in there, and if you have SMB multi-channel or RDMA network cards, we'll come to those in a second, a live migration can use that as well for very fast live migrations. And that sounds like cool technology and all that, and it looks good in demos, but it's actually useful in the real world if you're looking to patch a whole cluster, because it makes your live migrations, you've got to live migrate 20 VMs off one host to another one, so you can shut that machine down and do some patching or whatever. That makes it much faster. If you're looking for networking traffic, not between hosts, but from a client to a host, or from a virtual machine to another virtual machine on another host, that doesn't use any CPU overhead and has very low latency, you should look at SRIOV network cards. Be aware that your motherboard and your servers need to support this as well. That gives you exceptional performance because it basically bypasses the software stack and projects a virtual NIC into each of the virtual machines. Depending on your network card vendor and model, you might get 4 or 8 or even 32 virtual NICs out of an SRIOV NIC. And you can still live migrate the virtual machine from one host to another. If the destination host does not have an SRIOV network card in it, it will still work. It'll just swap over to the standard networking stack. There's a whole bunch of other technologies that work with HyperV. So there's task offload for IPsec encryption and decryption, data center bridging, which is an alternative to software quality of service. There's received side scaling and virtual machine queue, etc. Make sure you read up about these technologies and see what they do. I talk a bit about them in the white paper as well. Your virtual switches that you create on each host has to match across all the hosts if you're going to live migrate, which you can obviously do manually on a smaller cluster, but if you have a bigger cluster, you want to perhaps use the logical switch in Virtual Machine Manager, which gives that functionality for free. And finally, Server 2012 R2 comes with a protected networks option, which means that if a virtual machine loses connectivity to a network, so clients can't get to it, it will automatically be live migrated to another host, as long as that destination host has access to the that particular network. So I'm briefly just going to swap over here for showing you network quality of service from a virtual machine point of view. So I have a network storage quality of service machine here. It's turned off so that I can make changes to these settings. If I go into the network adapter here, so this is from a virtual machine point of view. Obviously, if you're looking at hosts, they can do the same thing here. So here's where I can set up the bandwidth for this particular virtual machine, right? How much maximum, how much minimum it can use. Or if you were doing this on a host, you have to use PowerShell to set that up for the host and carve up the 10 gigabit or 20 gigabit if you team two NICs together for all the different types of traffic. Storage is probably the most interesting part of virtual machines, right? Most everybody can relate, who's got some experience with servers. We can relate to CPU, and we can relate to memory, and we can relate to network cards. All makes sense, right? But for those of us who were around when we had physical servers, like a long time ago, before virtualization, we knew that setting up your storage right was the difference between a poorly performing and a well-performing server. Now, some people seem to totally forget that. They just put a whole bunch of virtual machines on really fast hosts that have really slow storage access, and that then is a recipe for disaster, because now you've got 10 or 20 or 40 or 100 virtual machines all accessing slow storage, and they're all running slowly, and there's absolutely nothing you can do about it. Doesn't matter how fast your network, CPU and memory and how much memory you've assigned to them, it's still going to be slow. So if you're going with a SAN, or you have an existing SAN, make sure that it's got a VSS volume shadow copy services hardware provider for backup. And if you need virtual machines to see directly into the SAN storage, you can use virtual fiber channel. That also does not preclude you from live migrating the virtual machine. So you can live migrate virtual machines that are connected to a fiber channel SAN. But for each host that needs access to a fiber channel SAN, you need 2 host bus adapters for redundancy, and you need iSCSI NICs if you've got an iSCSI SAN. And for the iSCSI, you want to configure jumbo frames and unbind things like file sharing and DNS on the NICs used for storage. They should not be used for anything else. So the option or the alternative to a traditional SAN is the scale-out file server. So if you have an existing SAN and you can pop a couple of scale-out file servers in front of it and save yourselves on host bus adapters and fiber channel switches. I've got a little sketch on that in a minute. But other than that, they can also be used with storage spaces. So a storage spaces solution is where you have boxes of hard drives, very simple boxes. We call them simple disk enclosures. And we plug hard drives and SSDs, a mix of both, into these boxes. We connect them using serially attached SCSI cables directly to our scale-out file servers, and they then manage it. So this is a replacement for a SAN, where 2 or 3 or 4 Windows servers act as your SAN controllers, and they take care of the data protection on your storage, using 2- or 3-way mirroring. You should never use parity for HyperV workloads. And they do the storage tiering, so they move the hot blocks to the SSD so that they run fast, and cold blocks that are not accessed are moved over to the hard drive for storage, or the hard drive tier for storage. Between your hosts, as in your HyperV host and your scale-out file server hosts, you can either use ordinary 10 or 1 gigabit Ethernet networking, and you can team a bunch of those together if you want to, or if you need really fast access, you can use remote direct memory access network cards. There's 3 brands or flavors of this on the market: iWarp, InfiniBand, and Rocky, which stands for Converged Ethernet is the last 2 letters. I'm not sure what RO stands for. Anyway, it comes in a bunch of speeds here, and it's on the horizon is even faster speeds than 56 gigabits. So this matches up to the fastest fiber channel SAN you can buy, but it's much more cost effective. And you need to set up multipath I/O over those 2 SAS connections. You want to have 2, of course, for high availability and redundancy. And there's some tips in the white paper on how to set this up. You can use 2 types of virtual hard drives for your virtual machines. You can use dynamic expanding ones, and you can use fixed size ones. Back in the day, we used to recommend fixed sized ones because they performed better. That's no longer true. Just be aware that if you use dynamic ones, you may oversubscribe the underlying storage and use more storage than you have. So be a bit careful of that. And using storage quality of service. So again, I'm going to demonstrate here. So if I go into the same virtual machine here, have a look at the settings. Again, it's got to be off to do this. And I go into my hard drive here, and I go down to advanced features. This is where I can set up quality of service for this particular hard drive, right? I can set a minimum and a maximum IOPS. And IOPS here are measured in a standard format that Microsoft uses in 8 kilobyte increments. So in-out operations per second. So that's fine, and that allows you to control a noisy hard drive that uses too much and slows everybody, all the other virtual machines on that host down. But you need to be aware that in 2012 R2, this is a per host setting, which means that if you've got 10 hosts and they're talking to a back-end storage, and you guarantee a minimum of 50 or 100 IOPS for a virtual machine across all of those virtual machines, if the back-end storage cannot deliver that performance to all of your virtual machines at the same time, this setting is not going to be enforced, right? Because there's no way that the HyperV host, because it's not talking to the back-end storage to tell it that, hey, I need more IOPS. So be aware of the limitation of that setting. That is going to be fixed in Windows Server 2016. Right, so here's what I was talking about before. So this is your new scale-out file server setup. We got a scale-out file server cluster with 2 nodes here, node 1 and node 2. They are connected to both disk trays, and of course you can have 3 or 4 disk trays here with more connections going to all of them. So these blue lines here are all serially attached SCSI connections. And then you have your HyperV nodes here, and of course you could have more of those. The ratio is not 1 scale-out file server node to 1 HyperV node. Normally you would see 3 or 4 at the most scale-out file server nodes in a cluster, and they could easily be serving 16 or even 32 HyperV hosts. And these connections are then either ordinary SMB TCP/IP network connections, 10 gigabit Ethernet or whatever, or they could be RDMA connections if you need that really high speed. So as I was saying before, if you have an existing SAN and you need more capacity, you're going to build a new cluster, but you don't really want to buy new host bus adapters and perhaps new fiber channel switches to accommodate your 10 new hosts that you're going to have in your HyperV cluster. You can put a couple of scale-out file server nodes in front of your SAN. They are connected using host bus adapters, just like any other host, to the fiber channel SAN. But these guys then are again connecting using ordinary TCP/IP networking, the red connections, or RDMA networking if you need that speed. Okay, so we've looked at all the hardware components that make all this up. Now we look at your management and how we're gonna manage all this. HyperV Manager is okay for a few hosts. It can manage, you can add in more hosts in there and see them, but it's not really designed for any kind of larger environment than 2 or 3 or 4 hosts or something like that. Anything bigger, you want to use System Center 2012 R2, and there's a virtual machine manager in there. It can do so much more than just manage virtual machines, though. It basically manages your whole data center. It can deploy Hyper-V and scale-out file server hosts to bare new computers that have no operating system on them automatically. It manages both Hyper-V and vSphere. It can manage your top-of-rack switches. It does the Hyper-V network virtualization, the new network controller to link out from virtualized networks. You can create clouds to abstract resources away. It allows you to deploy virtual machines and services, which is a bunch of virtual machines together in several tiers using templates. It manages all your storage, so you can classify all your different storage. You could have a slow bronze one and a medium silver one, and you could have really fast gold storage. And Virtual Machine Manager will automatically create iSCSI LUNs for you and unmask and mask on fiber channel SANs, etc., etc. Savision has a cloud advisor that plugs into Virtual Machine Manager, which I think Justin is going to mention briefly towards the end of the presentation, and that's a free download. Because you've already bought System Center, you buy that as one package, you will also get Operations Manager. And of course that's a whole other webinar just talking about what it offers, but in short it gives you, it's got these management packs with intelligence in them to talk to your Hyper-V hosts and your scale-out file server host and your virtual machines and your hardware, so it knows if there's a fan broken in one of your, Lenovo or Dell or IBM servers, whatever, HP servers, etc., etc., etc. It does lots and lots of stuff, so it gives you that one pane of glass to see how your environment is behaving, including from a performance point of view. Some of the performance I'm about to show you, performance management, can be surfaced up in dashboards inside of Operations Manager as well. Savision has a cloud reporter that plugs into Operations Manager that gives you some stuff there as well. And if you have distributed applications, so several virtual machines with different roles to play in the delivery of a particular service, you can use Savision's Live Map Unity to discover and see those. Alright, so now we've talked a lot about performance planning and how the different technologies work together and which ones you may need depending on your workloads and depending on how many virtual machines you're going to need and how your cluster is going to grow, etc. And all those things. But what if you, so you put it all together, you bought the hardware, you've installed it all, you got it all up and running, boss is happy, you're happy, that's always a good day, and then there is some problem with one of the virtual machines. So how do we track down performance issues? So I'm going to demo this in a minute, but I just wanted to talk briefly about it on this slide here. So the first thing you need to realize is that Task Manager, that old stalwart that we all know about, is you right click on the Task Manager on the Start Task bar at the bottom and you go to Task Manager to see what the problem is. In the host, it's not Hyper-V aware. So don't go to Task Manager to figure out what's going on if you're on a Hyper-V host. And if you go into a virtual machine and it has performance problems and you try to use it to track down a performance issue, where is it CPU, is it memory, what's the problem here, it definitely lies, because the virtual machine is being lied to continuously by Hyper-V. It doesn't know the real value of any kind of CPU resources. If it has dynamic memory, it has no idea what memory it gets assigned to it from second to second. It doesn't understand about the virtual networking. It doesn't know any of that stuff, right? So what we should use is Performance Monitor, which I'll get to in a second. I wanted to just mention VM metering. This is new in 2012, and it's also in 2012 R2, of course. And this is really designed for hosters to go in and turn on metering for selected virtual machines, or all of them, to gather up how much are these virtual machines using, how much processor, how much memory, how much disk over time, so that you can charge them back, right? And say, well, this virtual machine used this much, so therefore you have to pay this much. And that might be interesting for your enterprise, but from a performance point of view, this is also a good thing to use if you have a virtual machine or a bunch of virtual machines that are misbehaving, but it is a slow moving thing that you can't spot at the particular time. Turn on VM metering using PowerShell and then do some measure VM, and you get a list of, is this virtual machine using a lot of storage? Is it using a lot of networking? What is the issue there? So back to Performance Monitor, right? So this is a tool that's been built into Windows for a long time. And it actually has counters that are HyperV aware. So there's a logical processor, a virtual processor, I'll show you those in a minute, and there's a whole bunch of other ones. These ones are the ones I mentioned in the white paper. Performance monitoring can be a bit overwhelming. There's lots of counters, and what do they all mean, and all that. So one of the things you should really do is you should baseline before your users knock on your door and tell you there's a performance issue. You should baseline your servers on a good day, right? When everybody's happy, you should baseline them. Okay, how much CPU load on average do we have on our hosts when everybody's happy and all the virtual machines are running fine? How much memory, how much networking, how much storage I/O is going on? Once we have those figures, when we have a performance issue, we can go back and compare to the baseline. If you don't have a baseline, you don't know what it should look like and what it did look like when everybody was happy, so you got nothing to compare to. So there is a PAL, is a Codeplex download, PAL. You can go and download that. It's a free tool, and it allows you to gather these sorts of logs using Performance Monitor. It's sort of a shell or an add-on on top of Performance Monitor, and it allows you to gather those logs and compare them and analyze them. And it's got some pre-set up templates with different counters that you can use. Anyway, I'm going to show you the HyperV counters in a minute when we go into Performance Monitor. Here's a few good ones. There's also logical disk. So here's where you're looking for a value less than 10 milliseconds for the disk seconds read or write. And if you have bigger values than this, you know that there's some problem with your storage. On the host, you can look at memory available megabytes. That will tell you where memory is at for your host. Is it depleted? Too many virtual machines using too much memory. For dynamic memory, so this is where you assign a minimum and a maximum amount of memory that a virtual machine can use. That can make it very hard to track down performance issues around memory. So there is a dynamic memory balancer, and there is a counter for that, and your average pressure there should be less than 80. And the network interfaces, of course, the output queue length is a good value, should be really less than 1. If it's higher than that, on an average, it's probably having a lot of work to do. So let's do some demo. That was me talking almost non-stop for 37 minutes. So let's see something a little bit more interesting than just PowerPoint slides. And I apologize for that, but there's really no other way of talking about planning. So here we go. This is Performance Monitor. You've got this built into any Windows machine you've got. So there's a few different things we can use here. These data collection set is, I won't go into those today due to time restraints, but here is where you build up things that you can collect performance counters over time, right? So this is where you would monitor for a day or an hour or whatever, so that you can then go back and analyze if the performance issue is intermittent and you don't know when it happens. But it all comes from this Performance Monitor. So this here is the graph. This gives you a minute and 40 seconds of a snapshot of a particular machine. At the moment we can see this processor time on my host here. So I'm going to add in some counters, which I do with this plus sign up here. So depending on which server you're running on, there will be different counters in here, right, depending on what's there. So I'm going to look at things like the dynamic memory balancer. So average pressure, we mentioned that before. So I'm going to add that counter in. I'm going to look at the logical processor. And I'm going to look at the hypervisor runtime, and you can see all my different counters here. So these are instances. These are my 4 logical processors here in my laptop. I'm just going to go for the total. So that's how much CPU the hypervisor is using up. And then I am going to look at spot So that's the logical processor, and then I'm going to look at the virtual processor. So this is what is assigned to virtual machines, right? So if I look at the total runtime here, this is per virtual machine, so I can either look at all of the virtual machines I've got running, I've only got one, or I can look at this particular virtual machine here. So I'm going to add that one in. That's my only running virtual machine at the moment. We're going to see in a minute what that looks like. Let's grab those other counters while we're at it. So we wanted to look at logical disk. So here's my logical disk, and average disk byte, so disk queue length we can add in there for my C drive, and we have disk seconds write and disk seconds read. I'm going to add those in as well so we can see that. I'm not going to do any networking monitoring in here because I don't have any network traffic, but of course you would go down to your network interface here and you would look at your bytes received and your output queue length, which is that one there, and I would choose which network card to monitor that for. Okay, so once we add in these additional counters, my graph is now going to light up with more values. As you move through these, it can be very hard to see which one we're looking at, so I can simply use the highlight button to see which one am I looking at here, right? So let's start off. So this is the virtual machine that I have running, which is right over here. And this is just a Windows Server 2012 R2 virtual machine that's running. Now I'm going to generate some CPU load in here and see where that shows up in the host. So looking at the virtual machine here, the green background, I'm going to start off some CPU load here. This tool is free. It's part of the sysinternals package. You can go to sysinternals and download that one. So I've now got 4 CPU stress threads running. I'll go back to my performance monitor. We should now see a fair amount of load having picked up here. We can see the actual values here, right? The figures themselves, and the graph tells us that there is a fair bit of CPU load. And if I had 10 different virtual machines running here, I could see which one is using up a lot of CPU resources. And the other thing we probably want to look at is storage traffic, because it's the one that is often hard to find. I'm going to turn these off again. So to simulate some storage traffic, I've got something called SQL.io. Again, it's a testing tool. It's freely downloadable from Microsoft. If you just do a search on SQL.io, and we're going to run that here for 10 minutes with the default settings. And it's got some settings on here what it's going to do, and this is going to, so this is now running the SQL.io IO as in storage performance testing on a virtual machine running on top of the hypervisor, or running in the hypervisor. And in this particular case, it is housed on my laptop's SSD, so it should give us pretty good performance, but we should definitely see some storage load if we go back to performance monitor here. Now that takes a little minute to set up, so it may not quite have kicked in yet. Oh yes, it has. There we go. Alright, so we can see here that my disk queue length for my physical disk in my host, and of course you would be looking at perhaps a scale-out file server or SAN here, but you would see the same values, right? The storage is not delivering fast enough. We can look at disk read per second, which is actually very good, but we can see that we got some serious spikes in the right part here, and this is probably either due to where this test is at, or it's due to the fact that SSDs are very good at reading. Hence these values stay relatively low, but they're not very good at writing, so that could be why we're looking at that there. And we have no network traffic going on here. So this is where you would add in your counters to track down where is the performance issue, what particular virtual machine is giving us the headache, why is it running slow, which resource is it using up. And this is one of those important things really. You need to have an understanding of your environment And where is the bottleneck most likely to be? You've got an old SAN, the boss doesn't have enough money to buy a new one. Well, that could be where the performance issue lies, but unless you do the figures and actually use Performance Monitor to track down these problems, you're just guessing, right? But with a bit of performance monitoring behind you, you can go with some actual figures. You can export these graphs to HTML and give them to the boss, and when you're using these data collector sets, you can then open them up. So at the moment we're looking at current activity, but if I open up a log here, I could then look at data over an extended period of time. This could be a whole day where I'm trying to track down which is the busiest time of the day. Okay, and that is me done. Justin, are you there?
Paul, thank you very much for your time. Just having a look in the Q&A in the chat session, we are not getting any requests or questions coming in, so it looks like everything was incredibly clear. So I'd love to dive into a little bit more detail about Cloud Reporter and Cloud Advisor, as you mentioned, just to give you an idea of what is possible with our tooling. For those of you who are not aware of Savision, we have a couple of products out there. LiveMap's been our main one, but as Paul mentioned, we have a free tool for VMM, which is Cloud Advisor, which will give you free tuning and optimization recommendations within your VMM for both HyperV and VMware platforms. As you can see from here, you have the ability to have graphs and health tips pop up within your VMM solution. Here's a list of some of the tips that will be in there to allow you to help right-size your servers as and when you are spinning them up, as well as keep track of them within VMM itself. Now, this is not a troubleshooting tool. It's just designed to help you make sure that you've got the right size tool, and strangely enough, it's the most downloaded by Microsoft field engineers that we have, as they're constantly spinning them up for their customers. Again, I mentioned it's a free tool, so feel free to download it. You will need one package per VMM console that you like to see it in. And so if you have multiple running and you'd like to share that with a couple of people, please do. There is a video explaining how to do it and very simple what the add-on will do. It ties in nicely with what we've got set up within Cloud Reporter. Cloud Reporter goes a little bit further step than just the troubleshooting that you saw from Paul and from our Cloud Advisor tool. It allows you to actually run physical reports from your SCOM console and produce those for management to see. So when you have to go and explain the figures of why the servers need to be replaced in the near future, you have the ability to not only prove it, but you can have a report pumped out to actually show the current usage, as well as where you've got components that you can recover from and where the maximum optimization is. It is a forecasting tool, so it does allow you to run a forecasting report based on the management packs within SCOM itself, and it builds a database within the SCOM management pack information that allows you to access, for example, 95 percentiles and less, that you can set the parameters for yourself. So you can run on the forecasting abilities. You can run, for example, a what-if scenario based around it. I won't dive too much into this end. What I'd like to do is show you that there is an online version that will show you a couple of reports from it. We are located here, Cloud Reporter, on the Try Now button. For those of you following along, it's www.savision.com/test-cloud-reporter. You can log in very easily, just submit the form. We may have your details ready for those of you who are familiar with us, and you can get access to some of the reports that can actually be pumped out. We mainly focus on HyperV, but we do the reports as well for VMware, the exact same reports to a good level, as well as specific scenario reports that are possible. So as you can see, there is a forecast report, which you can actually drill down based on the red, green, yellow scenarios. So you can drill down into the red components and actually see why we're forecasting that as a potential issue for you in the future. There's a resource overview per host, and we will do it per cluster as well, so that you can target multiple ones and have a look at if a group of hosts will actually be covered, which is unfortunately at the moment in no other tool except for Cloud Reporter, but is accessible from the information that SCOM is pulling. So we found a way to bring that to the surface, and these are the reports that you can actually get out of it. We highlight the areas of tension so that you can very easily go to management or purchasing and mention to them why you need that very expensive new 64 gig Hyper-V server. Memory exhaustion predictions, idle virtual machines so you can win back resources, powered off virtual machines, again the same sort of idea, and virtual right sizing. These are just a list of some of the reports. If you'd like access to this product, we do run an evaluation license for it. You can already download it from our download section. It is a management pack that sits within Ops Manager and will actually start working without a license key, as it does need to build the forecast reports over a period of time. After 3 days, then you will be able to run all of the reports with no issues. You will need a key in order to view the reports. Please contact our sales department for that key. That's Cloud Reporter. This is the forecasting backend reports, but there is also another solution that does come with Cloud Reporter and is actually tied very neatly into our live maps. As Paul mentioned, there is a way that you can group your Hyper-V service per service within Ops Manager. The very simple tool is live maps itself. I won't dive into live maps as we have many other webinars and a sales team standing by to answer your questions about it, but I'll just like to log into the web interface for my SCOM so that you can actually see what that would look like. So the intention is, once you've grouped your components together, your servers together, so your Hyper-V servers together, you can actually have a list of services and their current health state. And as Paul mentioned, when you're having a performance issue, it is imperative that you find out what that issue is as soon as possible, because the more downtime you have within an issue, the worse your business is suffering from that. Now, live apps will get you to the exact issue immediately, and from here, from the web interface, you can launch what's referred to as vital signs, but as a real-time dashboard for that server. See, my pop-up's being blocked. I'll try that one again. And it launches into a browser and will go PowerShell direct to the server, to the Hyper-V host, or to the individual server on the Hyper-V. As you can see here, it is Microsoft based, so we'll need to be Exchange, Hyper-V, SQL, or Windows Server. Let me open up the Hyper-V servers for you. These are my servers in Canada. So once I've clicked on the server, it does make the connection. There is a small pause as we're trying to do the PowerShell connection over internet. And once that meter is done, we will have the real-time performance counters from the server exactly there. When I say real-time, you'll actually notice in some of the graphs here, for example, there's a little black dot, and the longer I talk, roughly about 15 seconds, you should see a second black dot pop up. That is the pull that we're doing direct from the server to pull the performance counters. And as you can see, it is very simple, user-friendly interface where you can actually look at specific KPIs and create a dashboard that can help you with troubleshooting on the moment. So we can look at the individual guest runtime, and I can just drag and drop a specific matrix that I want to have a look at, 9% guest runtime. So I'll pull that up here, and you can see immediately that there are issues actually happening on the server. That's why I like grabbing this one. There's a memory problem. We can dive into the average pressure, look at the NUMA load balancer, grab a performance chart for that. Make this dashboard a little bit more appealing. That's the NUMA load balancer. And I can add comparison graphs instantly from this and start looking at it. Now, you will actually spot on here that there are little markers popping up. These are alerts either directly from the server itself, from the log file, or from Ops Manager, or from Service Manager if you're using that from System Center, or specifically from our parameters. So you can actually set a max and min as admin in here, or as a user, depending on the level that you allocate to them in the web page. And Vital Signs will alert you, or the real-time dashboard will alert you once that max or min has been hit. So all of these seem to be Vital Signs incidences for this. There is obviously the question of the reports and performance counters being pulled from SCOM. Now, I'm just trying to see if I can locate a graph that we're doing from the Hyper-V management pack at the moment. It shouldn't be on the system here. Yeah, so I'll grab processor time and highlight this for you guys right now. So processor time, you'll actually notice on all the graphs up until now, you're just getting the value as and when I connect it to them, so on average pressure and the NUMA node. but you can actually use the slider down here at the bottom for a very easy interface into the SCOM data warehouse information. As you can see, the longer I move back into a maximum of a week time, the more I can actually see the performance counters. This is obviously my demo environment, so not very exciting, unfortunately, but you can see the actual work that SCOM's doing and the averaging that it does as well, based on the load that's in here. If any tickets are raised, you'll be able to click on them in this in this graph and be able to see them as well. Or potentially you can dive into a little bit more exciting information, which is the virtual machines running on the host. I can have a look at the issues that are currently on there. As you can see, current pressure is an issue for one of the servers. Let's have a look. There's the alert instantly for 30 seconds. Virtual networks, virtual hard disk, all the information at a fingertip available for you. Just getting the graphs and performance counters popping in there, as well as the properties. This is bundled with Cloud Reporter, so the intention is that you get not only the forecast ability so that you can see everything that's going on, but you can also help it real time to keep your uptime on your HyperV service and on your HyperV service as maximum as possible. With that, feel free, as I did, to log into our webpage and locate this tool. It is usable. This is exactly how it looks outside the box. Literally, you point it towards the server and you get these KPIs, which you can then drag and drop as admin or as user level. If you have any questions, I have a sales team standing by on the phones, really willing to take your questions and arrange for access for this product on your own environment as well. And that, I think, is from my side. So I'm just going to have a look if we've got the slides as I've promised. I wanted to end with a little bit of contact details because we got a lot of feedback from people that Paul is incredibly exciting to talk to. So I'd like to make certain that you can actually get access to him. I'll leave this slide up on the screen here as well. Wow, that picture of me is old. I don't have a beard anymore. But feel free, please, to reach out to Paul. We thank him again for running this very in-depth HyperV look. Hopefully it's given you guys some ideas and some focus points moving forward. It will be available on the near future from our webpage to download with full audio. But as I said, please feel free to reach out to Paul directly or head to his blog. Paul, thank you very much, sir. We will probably see you again soon. And thank you for your time. And again, for the attendees, thank you very much for attending. And hopefully some of your questions were answered. If not, please contact either Paul or myself on the links on the screen as well. Till the next time. Thanks, Paul. Have a good evening. Talk to you again soon.
Thanks, everyone.
Cheerio.
Bye.